In this video, we're going to have a look at sockets. You've probably already noticed that below MISC here, there's this menu item called sockets. Now, assuming you know what the WebSockets already are, you've probably already been curious at this. So let me show you what it's for. You see, Magic has extremely strong support for WebSockets using SignalR. SignalR in .NET Core version 6, of course, is ridiculously scalable and can easily accept, I don't know, thousands, if not hundreds of thousands of socket connections towards the same server. Obviously, there are some restrictions on your particular cloudlet and stuff like that, but it's a very, very scalable and high-performing WebSocket library. Now, if I subscribe to, for instance, a message called foo, right, then it creates a list of subscriptions here. Here's my subscription ID. It has my username. And as you can see here, it has a list of subscriptions. I can also subscribe to multiple messages. And this is the message name, right? If you want to think about it in traditional computing terms, you can think about it like the function name. It's not entirely correct, but okay, correct enough. If I now open up a new browser window, let me set these two up side by side, such that you can see it in real time. And I now go to the evaluator. Then I can write socket, sock, and then you see signal here. Now I can provide a name, foo. And let's see its documentation here. Open up this guy and find magic.lambda.sockets here. And let's find signal, right? So as you can see here in the documentation, this is basically the structure of a socket signal, basically transmitting a socket message. So if I now go back to this and I write args, and then I write, for instance, my tab is funny, arg1, foo, arg2, bool, false. If I now execute this and notice the name of my signal here, then if I don't select any particular parts of my Hyperlambda, of course, if I execute everything, you will see immediately it catches the socket message here, right? Because this window here has an open socket connection towards my particular cloudlet. When I'm invoking this Hyperlambda here, what I'm basically doing, I'm transmitting a socket message to all relevant listeners. If you see the documentation here, I can also apply roles here. If I now do, for instance, roles foo, then this guy over here doesn't belong to the foo role. So when I execute it, he doesn't get the message, right? However, if I apply the role root and I execute it, he gets the message. I can also transmit the message bar, at which point he gets another type of message here. So you can see now he gets bar, etc., etc. Now, this, of course, goes also into the CRUD generator, such that when I am in the CRUD generator here and I choose any database, for instance, ISA CRM, it doesn't really matter. I can configure one table. Then I scroll down here at the bottom and I see the signal R checkbox, publish, boom. My HTTP Web API has socket support upon write invocation. What's a write invocation? Anything that changes the state of my database, implying create, update, and delete, but not read. But create, update, and delete will now automatically be publishing socket messages upon invocations to these endpoints. And we can actually look at it. If we now see status in ISTA CRM, we credify this table, then we go to HyperID, we expand modules, we find ISTA CRM, and then we find status delete, for instance, here now. You will see down here somewhere at the bottom that it's actually invoking the signal called ISTA-CRM.status.delete. The last part, it's the HTTP verb. So if I now open post and I go to the bottom, you will see it says post. If I open up put and I go to the bottom, it says put. Now, the default authorization for the sockets.signal invocation basically became becomes the same authorization as the endpoint itself. So basically, you have to be a user that's authenticated and authorized and belonging to the role of either root, admin in order to actually get this message on the client, regardless of how many times you connect with a socket connection to the backend server. However, this can be changed. When you choose Aista CRM and you choose status, you can actually change this as you see fit. If I now check off publish, I'm getting socket messages. Now it's inherited. That's what we just looked at. I can have none, meaning anybody gets the message. They don't even need to be authenticated. Or I can specifically add a bunch of roles. Role 1, role 2. Or I can choose groups, implying users belonging to a group. You see, when you have a socket connection from the client to the server, you can actually add users to groups, one or more groups. A group can be, for instance, chatroom 1. Okay, that's a group. Chatroom 2 is another group, etc. Or I can specifically mention users. For instance, my username is polterguy. Now only polterguy is getting socket messages on writing occasions to this particular endpoint. So anyways, this was a short video because it's very, very simple to understand. Unfortunately, sockets aren't simple to understand. However, if you click the documentation and you find the magic.lambda.sockets here, you can actually read everything about how it's working and how to implement sockets in your own Angular client. Here's Angular code to actually create a socket tunnel from your browser to your backend using Angular. And then you have documentation for how to signal socket messages, how to subscribe to specific messages on the client, etc., etc. And as you can see, here are the arguments and explanations of groups and users and metadata. Anyways, that was it for this video.